Good morning, coders. So since nobody really dropped any ideas for the next project, I'm just gonna start another game. So our last game was kind of like collect, move back and forth. So this time I kind of want to build a platformer. So we're gonna learn some cool concepts such as gravity. How do we add gravity to our game? We'll collect some coins. We'll just basically remake Mario or whatever other kind of adventure game we'll want. So platformer. So let's hit Game Lab. So, back on code.org, we're going to studio.code.org projects, log into your account, then you hit create, and you go back to Game Lab. We're starting a brand new game. So until we get a real theme, I'm just going to call this platformer. And we'll come up with a better name as once we find out more about what this game is all about. So here we are, platformer game. First things first, of course, we're gonna need to make a character. So our character, let's see. I'm hoping we have a Python. No Python. Bummer. Let's see what characters they got here. Aliens, box. Maybe it'll be a floating box. That's kind of cool. Oh, a gnome. I like the gnome. Green monster robot, all these kid sprites, pink monster. I really wanted to make a python, but I'm not going to attempt to draw that on this. So for now, the gnome looks pretty legit. It's not going to really have an animation, it looks like, but we'll see. So we're going to have to go left and right. We can change the sprite and add animations to it later, but for now we'll have a gnome left. And if you remember, we can duplicate it and we'll put gnome right. So then we at least have some sprites for when the gnome's walking left and right. All right, so then we go to code and let's get our homie Nomi onto the screen. My mom runs a daycare and there's this little kid, Max, who he was obsessed with gnomes for so long. Yeah, and so like my Nomi is like something he would always say. It's kind of cute. All right, so var sprite. Let's get the sprite out there, and I'm gonna name it gnome. So gnome create sprite. Again, probably we're gonna start. We're probably gonna want to put a platform at the bottom of the screen. So we're gonna probably start the sprite at around x of. That's fine. We can start x in the middle and y of maybe 350, and then in the world we need to draw the sprites, and then let's see. Oh, I forgot to set the sprites set animation gnome.set animation. It's just easier in blocks. You can actually do drop down instead of typing it. There you go. Sometimes easier to write in text, sometimes easier to write in blocks. All right, we got our gnome. He's a little low to the ground. Let's try 300. Yeah, that's good. I think he's kind of big, and if we're gonna have multiple platforms for him to jump on and stuff, I'm gonna scale him down a little bit. So scale is a multiplier. If you put a 2, he'll be twice as big, and if you put a half or 0.5, he'll be 50%. He'll be half the size. So I'm gonna put 0.75. There we go. That's better size gnome. Okay. So first things first, we need to make it so that we can walk left and right. So I'm just gonna jump straight into functions this time. So we're gonna make a function walking, or controls we'll call it. What did I call it last time? Controls works, I guess. So we'll call it controls. And then in here we need to do an if statement. I mean, I honestly like using blocks. Like, I could write out if blah blah brackets, and then I think it's key. Oh, thankfully we have this autocomplete. If key down left, then we move the gnome to the left. Gnome. You know what? I'm not gonna start moving the gnome yet because I think in a platformer game like this, like in Mario, it's not actually the character that moves, it's the background that moves, because we're going to have a ton of stuff off to the right of the screen, like different platforms that are going to come in. And so when we press left or right, it's actually going to be the background sprites that are moving, not the gnome in this kind of a game. So we're just going to write out the basics, left and right movement. And in this one, we're going to jump. So the first thing, well, we'll fill these out in a minute. So I guess now we're going to need a platform, some kind of ground platform, and we're going to need some way, another vertical platform that he can jump on. So let's go ahead and, so we could do this in drawing. We could do a polygon or a rectangle. The issue is, as far as I know in GameLab, if you were to draw a rectangle, so a rectangle would be really easy. So I could put a rectangle at right underneath the gnome. So at x of 0, and we're going to go y 300. And then what's the command? So xy, that's where it starts, and then the width. The width would be 400 pixels, the whole width of the screen. And then the height would be maybe 40. Let's see what that looks like. Okay, so I need to move it down some more. 350, 355, 352. Nope, 351. Looks like 350 was just about perfect. Okay, since there's that little border, that looks good. And then I'll just make that so it covers the whole bottom part. There we go. So now, like, it looks like there's a platform, and maybe I'll leave this rectangle for now because it'll, I'm gonna get rid of that stroke. All right, so now, I mean, it looks like ground, so that's kind of good, but we're actually gonna want to have a sprite because the issue is if you do a rectangle like this, there's no way to detect collisions, and we're gonna want the gnome, if he's touching the ground, then he stops falling because we're going to add gravity to this game. So when you press up, the gnome jumps and falls back to hit the ground. So we're going to need some kind of gravity. And you can see in our collision detection code, sprites. Sprites dot is touching. Is touching is really the key here to knowing if we're on a platform or not. So I can create edge sprites. That might be useful someday. Yeah, but for now, even though we have the rectangle, we can't, let's go into see examples of is touching. So you can see that is touching takes a target, which is a sprite or a group. So if the gnome is touching, it has to be another sprite that we pass into that method, into that as the parameter, the target. It has to be another sprite. So I can't pass this rectangle into there. So that's the issue with using a rectangle for drawing, is we won't be able to detect if the gnome is touching it. So we're going to need to draw our own background. So thankfully this kind of gives us an idea of what size it should be. So we will do a nice rectangle of, how do we set the pixel size? Resize the drawing area, and I want the width to be, I don't know, 800 pixels? No. And the height was, reset the whole thing. So we're going to do 800 pixels wide and 50 pixels tall. Resize. And it didn't let me resize it because I still had that maintain on. Resize. There we go. So now we have our ground, and the reason I didn't make it 400 is because I want to like show you we're gonna have this sprite scroll to the left, and that'll make it look like we're walking. So it's kind of a cool feature, is just the ground moves and it'll look like the gnome is moving. You'll see hopefully by the end of this episode. So I'm just going to dump the whole thing black, and then we'll just do, maybe this will be grass someday, but I'll just do like a little yellow line like that. Okay, very basic. Like I said, I'm not the greatest artist, and this is a coding lesson, so I'm not gonna put a ton of effort into the drawing at this moment. Okay, so it's got a little character now. So later on, maybe in between episodes, I'll get one of you to make some awesome background for this game, but for now, I'm just going to call this ground. Alright, so now we have a ground sprite, and what we want to do is get that ground sprite right where our rectangle is. So same way we made the gnome, we're going to make a new sprite, call it ground. We're going to place it at x of -2, y of 351, and then we'll do sprite.setGround.set animation to be the ground, and let's go ahead and run it and see what happens. So the height was 50, and I guess in our animation this height, I thought I made it 50 also, but it looks like, must be that rectangles are drawn from the top left corner of the rectangle, sprites are drawn from the middle coordinate. So yeah, because see there's kind of some black over here. So actually I don't want the x at -2, I probably want the x at like 400, so that'll give us the left part. Yep, that should be the left part. And then the y, I'm going to drop the rectangle, and the y of 350 plus 25, so 375 in the middle there. There we go. All right. So now, if I press key down left, what do I want to do? I want to actually make the ground start moving to the left, not the gnome. This is going to make it so that we could draw an entire map. Like you could set, let's see what the max width of a sprite is. I'm going to draw my own. And I want, let's say I wanted my entire map to be one giant image. Let's try, I don't know, 10,000 pixels. Can we do 10,000 pixels of ground resize? No, it didn't work. Oh wait, maybe it did. That's weird that maintain aspect ratio just gets, wow. It says it's 10,000 pixels, but the screen only goes to 800. So let's see if I can, yeah, if you see on the bottom right, kind of down here, I'm not sure how I can actually zoom all the way out. What does this do? Oh, that's the size of my pen. Flip vertically, line image, crop the sprite, resize the drawing area. So yeah, it says it's 10,000 pixels, but I'm not convinced I can actually draw 10,000 pixels wide. Like there's no, I don't see a left and right. Oh, there we go. Okay, so if you hold the middle mouse button, you can actually scroll left and right. And let's see if I'm just missing it. Oh, or if you hold control and use your mouse wheel to scroll out, we'll just keep zooming out. And we have, there you go, like a massive sprite that you could do. So it looks like code.org does let you could make a massive map all one sprite. But I'm actually just gonna repeat my ground sprite over and over again. And I'll show you how to do that. Okay, let's delete that. Gone. Okay, so here we go. We have this. So if key down white, left, we're gonna do ground.x equals, remember this counter pattern, ground.x minus 5. So when I'm walking left, nope, I did it backwards. We're gonna do plus 5. And that's kind of backwards from the gnome because we wanted to move opposite of what the character would because it's the background. So I press right, we're gonna move minus 5. All right, nice. And then if I go left, the ground's left. So it looks like the gnome is moving. If only I made it animation flip. So we're still gonna flip the gnome's animation. Gnome.animation 1. Gnome left. gnome.set animation. Gnome right when I press the left and right arrow keys. Alright, so look at that. We have a gnome walking back and forth. Pretty cool, pretty cool. Oh, and you can see there's where it goes all black. And then if I keep walking to the right, eventually when I get to 400, I'm assuming that the sprite's going to stop moving. It's hard to tell. So that's because I only drew on. So let's go back here and I'm going to scroll to the right. There we go. Let's draw some more. Now it gets red over here. Ah! Made it to red lava. You guys will make much better drawings than me, I'm hoping. And look at that. So when I keep going right, it just kind of glitches out. That's kind of cool. But we're going to make it so that the sprite reset. We'll probably have 2 different ground sprites. And then when there'll be one over here and one over here. And then when this one gets all the way over, we'll reset and move it this way. And we'll keep moving both of them. And they'll just flip their order. So with 2 sprites, you can essentially have infinite ground. You just, because we need to viewing one on the screen, and then we'll have one off screen, and we'll reset it over and over again. So with 2 different ground sprites, we'll have an infinite scrolling game for the ground. It's really cool how it glitches out. I wonder if it glitches out to the left. Let's go over here. It's just a pure black. So whatever the last sprite was, it just keeps showing that instead of, I would have assumed it would have went to white, but cool. That's what, I don't know. You just got to test your game and see what happens, right? All right, so the next thing we're going to need to do is jumping, and I think after jumping, I'll probably end this episode. I might even want to wait till next episode for that, but we're fine. We got time. Get out. There we go. All right, so now to jump, if I press, okay, so we're going to add gravity to our game. I don't know if you've learned about gravity in FOSSA yet, maybe, but what gravity basically is, it's a constant force that pulls downward to the ground. So we're going to add to the gnome this constant force. So gnome.velocity y equals -1. And watch, oh, that's a vertical gravity. Oh, that's the issue, is I didn't redraw a background sprite. So that's why it was glitching out. Okay, so drawing, background color, white. See, I forgot my own pattern. You always start with the background, then controls, then draw sprites. Now, I gave the gnome fake, there you go, now you can see the white. So I gave the gnome opposite gravity. So that's if gravity was pulling up. It's because in GameLab, the y coordinate 0 is at the top, a little opposite from math, and the y coordinate 400 is at the bottom. So we're going to add a +1 gravity. Now the gnome is sinking. Goodbye, gnome. Miss you. But, so this is constantly going to pull the gnome to the ground, which is perfect. But the issue is, when we start jumping, that's what we want. But the issue is, once we hit the ground, we want the gnome to stop. So we need another if statement that says, I'm not sure. Yeah, I'm going to leave it in controls for now. I might break this out into its own function later, but we'll see. So if gnome.is touching the ground, then gnome.velocity y equals 0. So now when he's on the ground, he's fine. Now when I press the up arrow, we're going to spontaneously give this guy a force vertical. So he goes super high. And we might have to change some things here with velocity. But let's one step at a time, getting ahead of myself. So if key down, up, then the gnome is given gnome equals -5, so he jumps. So run, press up. So when I hold up, he just keeps flying up. It's not quite what we want. We want it so we just like tap up. So right now, if I tap up, so there's some different controls on here. So instead of key down, we're going to use key went down. So you can't just hold the up arrow. So if key went down up, then I can't hold it. I have to just tap it. Okay, and obviously he falls to the ground very fast. So let's give him a velocity of negative 100. Okay, now it's an instantaneous jump. So we're going to need to do some work. So gravity actually doesn't instantaneously set your velocity to 1. If we add a positive force in the up direction, then we're gonna, we're actually accelerating. Gravity actually adds an acceleration down. So what is acceleration? Whew. We could do some calculus. Basically, so when you say this counter pattern, ground.x equals ground.x plus 5, when I press the right arrow key, that's changing. So it's setting position equal to position plus a number. So that's velocity. And then, which is technically the integral of your position. You'll learn calculus later, it's fine. And then now I made him instantaneously move to the top 100, which doesn't look like a great jump. We want him to slowly come up and slowly come back down, right? So instead of just setting for gravity, instead of just setting the velocity to 1 instantaneously, we're going to slow down the velocity the same with the counter pattern, the same way we did with position. So we're going to write gnome.velocity y equals gnome.velocity y plus 1. Okay, and then I'm going to go back to negative 10 velocity and see what happens. So now when I press up, woo, look at that. He jumps. We got a jumping gnome. All right, so maybe not, it's not quite negative 20. I think I want him to jump a little. Ayo. Ayo. Now he's rocking it pretty high. 15, let's try that. Okay, so now what happens? When I press the up arrow, I instantaneously get a velocity. I apply a massive force to the ground, get an instantaneous vertical velocity, and then gravity constantly slows down my velocity. So this is just like it would work in, this is how gravity works in the real world. If you were jump, you would probably, when you jump, you bend your legs, you apply force to the ground, boom, you get a massive velocity upwards, and then your velocity is slowly pulling you down. So you're the fastest the split second you jump, and then your velocity decreases as gravity pulls you back towards the ground. Okay. Maybe we could draw the force diagram. I don't know do you guys know about force diagrams yet? Hit me up in the comments, like and subscribe, but maybe we could show the force diagram with an arrow on the gnome. That would be an awesome physics integration. That science, I think I'm going to try and do that one of these episodes. Let me talk to our FOSSI teacher and see what you guys are learning right now. But we have a jumping gnome. Next episode, we'll add a new platform that the gnome can jump on, and we'll probably improve the background sprites. For now, that's how you add gravity to a game. When you press up, you get instantaneous velocity. When you then gravity, this command is basically gravity. Gravity constantly pulls you back to the ground. And then if you're touching the ground, you stop moving. Your velocity goes to 0. So the order of this matters a lot. Make sure you put it in the same order. If I put this up here, let's see what happens. It just doesn't work at all, because it's gonna go up first, but then when I'm touching the ground, it sets it instantaneously back to 0. So make sure it's in this exact order: gravity, then ground, then our jump velocity. And you should have a working gnome gravity. You make a better character than a gnome. I don't want to see the standard sprites. You guys are talented artists. All right. That's it for this episode, coders. I will see you next time. Have a great day, and happy coding.